We will now discuss the next item, the continuous contour trench and the manner in which it has to be executed, as well as the methods of negotiating the CCT while crossing a gully. Let us see this drawing. This is the plan, and we have a ridge here. It could be the top of a hillock or it could be the top of a high ground, and it is steeply sloping and gradually sloping at the end, and this is the foot of that slope. Further down below, the gully continues, and when we see this in sectional elevation, it is something like this. We have the ridge here, which means it is sloping this side down and it is sloping this side down, and with the ridge here, with the steep slope here, and the slope may get gradually eased out, and this could be the foot of the slope or foot of the hill, and it would be further having a gentle slope down below. In such a situation, we can construct a continuous contour trench along the foot of the hill or foot of the steep slope, as shown here in the sectional elevation and again as shown here in the plan. This is a trench something like this. If this is the ground level, the trench has got slopes on either side. We can give a slope suitable for the type of soils there. If it were to be ordinary soils, it could be 1:1 slope, which means 1 horizontal to 1 vertical. This also is 1:1 slope. It could be for a depth of 1 meter and a bottom width of 1 meter. This type of a trench would be stable even when it is filled with water. The idea is that this would get filled with water during the times of rains, and it will get filled up number of times during the rainy period, and it will get percolated, and it will also have seepage. At every rain incident, this is likely to get filled up partially or fully, and it is going to recharge the water table wherever such trenches are constructed. It would recharge the water table, and the seepage flow that occurs would make the land down below have enough moisture for raising rain-fed crops. Even during a drought period, if this trench is done on the upstream side of the cropped land, then it was noticed that the crops here down below the trench were able to withstand a drought spell of 20 days or 25 days, and there was no problem at all. Whereas if this trench is not there, and if it is just a land slope like this, then the droughts were severe and the crops withered away. So therefore, this has got two advantages. The continuous contour trench excavated has got two advantages. One is it recharges the groundwater table, and the seepage flow would make enough moisture available in the root zone of crops down below. It would also be able to support any horticultural crop along with any other rain-fed crops. Horticultural crops also would get adequate moisture for the root zone of the trees, and there would not be a need for irrigating the horticultural crops. Now let us see the various issues about the continuous contour trench. We can do that continuous contour trench CCT at the foot of the hills, but what is it that has got to be done along the slope of the hill? For example, in the plan here, we have indicated here staggered trenches, which means the water rainfall runoff would get collected here, and the rainfall runoff here would get collected here, and this is staggered. It won't be one below the other. The idea is the rainfall runoff occurring in the slope of the hill would be intercepted through these staggered trenches, and when these staggered trenches overflow, then the water will go down and would get collected in the CCT. Now, while excavating these staggered trenches, we have to follow the conventional practices done in the forest department. Along with the excavation of the trench, tree plantation will have to be done. The tree plantation is roughly indicated on the downstream side of the trench, the tree plantation. Like that, the whole slope of the hill has got to be planted with trees. This will prevent the soil erosion, and it will also create a microclimate which is suitable for the downstream crops and for the incidence of rains during the non-monsoon period. So, there are certain advantages with the tree plantation as well as the staggered trenches. There are instances where the slope of the hill or steep slope was not treated at all and just a CCT excavated. The risk in that case is soil erosion would take place and it will get filled up. This CCT eventually will get filled up with the eroded soil, and the sustainability of the CCT will not be there unless the slope also is treated. So, that is the first concern. Then the second point is, when the CCT negotiates a gully, this is a gully which is nothing but a small nala or vagu, a small stream, and the CCT is supposed to be continuous and it has got to be along the contour. So, it should not be broken, it should not be taken anything other than a particular contour, it should not have a slope. So, it is continuous without slope, and when such CCT is excavated, at some point of the place we are bound to cross a gully. That is shown here. In this case, the CCT crosses a gully. When it crosses a gully, then what happens? The rainfall runoff of this entire area is collected in the CCT, and during the heavy rains, there would be more flow in the gully on account of the catchment drained by the CCT. Earlier, this gully was having some catchment and certain amount of flood discharge. To that flood discharge, we are adding also the flood discharge coming from the CCT on either side. So, there are instances noticed wherever the CCT is done and left at the gully, the runoff in the gully down below has increased several fold, and it has caused erosion along the gully much severely than what it was earlier. That is because we are draining the rainfall runoff of the big area through the CCT and allowing it to join the gully. This happens only during very heavy rainfalls, when the CCT is filled up with water and when a very heavy rain occurs, then it will flow through the gully. So, in such cases, because it has got to be sustainable, it is advisable to have a mini percolation tank across the gully at a suitable place on the downstream side of the CCT. As shown here, this is the CCT, and downstream side of the CCT is this mini percolation tank earthen dam, and this has got a submersion area. The idea behind this mini percolation tank is that when heavy runoff occurs through the inflow from the CCT, it would be impounded here, it would be stored here, and this will be absorbed. The flood will get absorbed in this mini percolation tank. Anything over its capacity, it will spill, and the spill water only will come and join down below in the gully. So, therefore, we have to absorb the additional flood water coming from CCT through some means, and that is through this mini percolation tank we can absorb the additional flows coming from the CCT to the gully. The third point is, when the CCT has to join the gully, it has to overflow a particular stone check, because it has to create submersion within the CCT and the water level exceeds a particular depth, say 0.7 meter depth. Then it can overflow the stone check and join the gully. If this stone check is not there at the entry to the gully, then the CCT will get drained into the gully. There won't be any water stored in the CCT. We require water to be stored in the CCT for the reason that it should percolate down below and recharge the water table. And if we don't have the stone check at the entry point of gully, there won't be a storage in the CCT and the entire water will get drained into the gully. So that is the third point. And there is another important issue with regard to excavation of the trench itself. This is the trench profile. The excavated earth will have to be dumped on the downstream side of the trench. For example, this is the entry side, that is the entry side, and when we excavate this soil, it has to be dumped on the downstream side and like a heap like this. And this also should be at a minimum distance of 1 meter, what we call berm. This 1 meter berm has to be maintained and this soil has got to be deposited beyond this point. The idea behind that is, if it is deposited very close to the cut section, there is a chance of this sliding back into the trench. And this minimum distance is therefore intended to see that there won't be any sliding of the excavated spoil into the trench. Now a word about the mini percolation tank. While designing the mini percolation tank, we have to provide for adequate surplus arrangement here. While providing the surplus arrangement, we have to calculate the catchment area considering the gully catchment area as well as the catchment area of the CCT also. The CCT has got a particular length and that will get drained into this gully, and that catchment area also we have to consider. And we have to provide for a spillage considering that this mini percolation tank is already full, and then when a heavy rain occurs, it has got to pass through the spillway, and this spilling capacity should therefore be calculated based upon the catchment area of gully and the catchment area of the CCT. There are working tables given with regard to the computation of the maximum flood discharge of the mini percolation tank, and also there are working tables given with regard to the quantities of work involved in the mini percolation tank spillway as well as its costs. So those things can be adopted for the purpose of the construction of the mini percolation tank. An important issue pertaining to the continuous contour trench is that it has to be aligned exactly according to the contour, and it has got to be continuous. This is not possible in some of the forest areas where the CCT is executed along the boundary of the forest. In the boundary of the forest, there is a need for a continuous trench along the border of the forest, what they call it peripheral trench. But then, as we know, such boundary trench will not be according to any contour and would be having slopes all along its length. When such boundary trenches are executed, it is necessary that another CCT is excavated within the forest area at some distance varying from 200 meters to 500 meters or 1000 meters, depending upon the distance of the boundary to that particular contour. When a CCT has to be executed